So what I'm going to do today is try out self-supervised learning in the form of encoder-decoder. So what this does is the encoder takes, in this case, an image and expresses it as a smaller amount of numbers, and then the decoder takes those numbers and tries to recreate the image. This is called self-supervised learning because it is kind of like supervised learning in that there is a target, that being to regenerate the image. But also, it's unsupervised learning in that it doesn't require labels. But yeah, so I have done the encoder-decoder stuff before, specifically in the first video when I was trying to do classification on the MNIST dataset. But this time I hope to do it better and will apply it to the generative network. Okay, so that's the data loaded. I might as well visualize a little bit because, well, why not? Okay, so that's images displayed. Again, they look quite ugly, but what can you do? So the next thing is to make an encoder and a decoder, which I'm going to do in a separate Python file because it probably looks nicer and it's easier to work with. For the architecture, what should I do? I can start with a linear model without doing convolution, and if it's not good enough, then we apply more strange stuff. Okay, so this is the basic encoder. It is simply 3 layers of linear with ReLU in between and a 10H at the end, just to make it look hopefully nicer. And the forward pass function is just, well, you pass it through the network. So yeah, now I'm going to instantiate this over here and pray that it works. Great. Okay, this is a different error. What could it be? Oh, okay, there. A bit of messing around with it, but it runs. So now for the decoder. The decoder is more or less the same, but backwards. Okay, so for the structure, I did the same thing, just linear with 3 layers, ReLU in between. This one doesn't have a 10H at the end because, well, you need to make an image. And as a last little side note, I reshaped it in the forward function incorrectly. Actually, one thing I can do right now is display something. What I'm going to display is a little 4x4, which means this is 5x5. I'm going to take an image and then reconstruct it using the encoder and the decoder just to see what it looks like right now. I don't expect it to look good. It shouldn't. It really, really shouldn't. But it'll be interesting. That is if it works. Okay, so this is what it looks like now. This should be expected because they're not trained. But you can see 2 numbers next to each other, and hopefully at the end of training, they'll look the same. So what we're going to do is we're going to regenerate the output by doing decoder encoder x. This will give me a bunch of images. And then what I'm going to do is I'm going to say the loss is, you take the loss function between x and the output. Another thing I'm going to do is put this in a display function so I can do a little example after every single epoch, as long as there is no breaking itself, which honestly is likely, but we can, I can hope. After each epoch, it should, that's not what it's supposed to do. Okay, a little bit of modification. Let's see if it displays. So it starts with noise, and then the hope is that after even 1 epoch, it'll look better than before. So yeah, I'm gonna wait for 1 epoch, see if it's working, and then, oh, ooh, that's pleasing. All right, and hopefully it'll look better each time. I'll run this and wait for completion. But yeah, looks good. so it was trading, right? This 4 has an extra like whatever this is. It's no longer a 4, it's a fork. Please laugh. Okay, so it finished training. It's still blurry, but I think that's okay. What I want to do is I'm going to try out some experiments on the encoded data. So first I'm going to take a random image from the data set and I'll pass it through the encoder. Okay, so I think it'll be a bit useful to know what the image looks like. Okay, so this is what the figure looks like. So this is a 9, and this is the encoding for the 9. So what I can do is I can kind of modify this encoding by just taking one of the numbers, let's say like pick an arbitrary dimension, and just vary it across this dimension. And hope is that this dimension represents something about the like visualization of the number, maybe like the slant or the size or the rotation, and that changing this number across the dimension will make like a smooth transition from one number to the next number. Okay, here goes nothing. It's broken. Decode, decoder. There. That's not what I hoped for. I mean, you can try it again with a different image. Okay, it kind of turned from like a 7 to a 4. It's still not great, but I guess the idea is there. Let's pick a different image. This one's kind of a 0, and it ends up at 6. What can I do to try to make it better? Yeah, so this really wasn't what I was hoping for. But I mean, this part worked. This part was good. So what I do know is that the encoding does in fact encode numbers. It's just not very obvious how it does it because this would have isolated what one of the dimensions meant, but clearly not all of this, like, space actually meant something. So yeah, but it was a nice experiment. It was fun. Oh, wait a minute. I started messing with it a little bit more, and I got this. It starts as an 8, and it becomes a 2. And that's a very clear 8, and that's a very clear 2. I'm actually quite happy with that. So yeah, so that's essentially exactly what I wanted. So finally, one video with a happy ending.